I think some of the challenge in some of these problems is just figuring out what the heck they're talking about. So here's the problem. You got a building, you got a fence that runs alongside the building. So it's coming straight out at us here, right? They tell me that the fence has a height of 4 and that it's 6 feet away from the building. Okay. Now, they want to lean a ladder from outside the fence up against the building. So I'm assuming that the ground extends out here and that the fence then leans just, it's like I want to do it a small ladder as possible. So I assume it's going to just touch the top of the fence. Now I could have it start in closer and end up taller, or I could have it start further away and end up, hitting the over there shallower. So the question is, what's the shortest length ladder? So let's call that length L, right? I want to minimize L. Well, in order to minimize L, I got to figure out what all the possible, you know, things I can do are. And so I need to pick a variable that describes the different ladder positions. So I think what I want to do is I want to call this length here X. So that would be the distance away the base of the ladder is from the fence. Okay. Um, the length of the ladder is going to be, I'm feeling like there's going to be a Pythagorean theorem in here because I'm going to have this side squared plus that side squared is that side squared. So let's just call this side here where the ladder, the distance from the ground up to where the ladder hits, let's call that Y. Um, so it looks like I can say that L is, well, how about if I go for L squared? I'm going to minimize the square of the length, and then the length will be minimized as well, because the square root function is always going uphill, so bigger numbers have bigger square roots. And if I can minimize L squared, then I'll have minimized L. Um, so um, so the L squared is going to be Y squared plus 6 plus X squared. What I need to do is I need to get rid of either X or Y. I can only have one variable here. So there's a relationship, and I haven't used anything about the fact that we're going to be just touching the top of the fence. So there's some triangles in here that are similar triangles. There's this little triangle, and then there's the big triangle that both have a right angle in them, and they both have this angle down here. So so there's some relationships. I can say that y divided by 6 plus x is the same. So that was vertical. Horizontal is the same as the vertical here. 4 is to x. So y is equal to 4 times 6 plus x divided by x, and I can plug that in. So L squared is 4 times 6 plus x divided by x plus 6 plus x squared. And there I have a function just of x. Minimize it. And I mean, at this point, it's just a matter of, that's the setup part. That's perhaps the tricky part, right? Figuring out what it is they're describing. Pick a variable that you can use to go through all the possibilities, right? You could go from a ladder that's really, really tall going almost straight up to one that's really, really long going almost flat, right? Probably somewhere in the middle is the shortest one. So anyway, I got that situation, did the algebra, did the geometry to figure out what the length is. Now I need to minimize it. So at this point, it's a matter of taking a derivative, setting it equal to 0. So here we go. The derivative of L squared with respect to x is, it looks like I've got no, it looks like I've got, I'm going to do a little bit of work here because if I distribute the 4 over x into this, I get 24 over x, or 24x to the minus 1, and then the 4 times x over x is just 4. I'm just trying to make my own work as little as possible in taking the derivative, so I'm going to take the derivative of this instead. So I've got minus 24x squared plus 0 plus 2 times 6 plus x to the 1 power times the derivative of the inside, which is 1. Okay. this will be maximized or minimized if this is equal to 0, right? I don't always set derivatives equal to 0, but I do when I'm trying to find tops and bottoms of hills and valleys, right? That's when the slope is equal to 0. So solving for x here, I think this is quadratic in x now. So I've got minus 24x squared plus 2x plus 12 equals 0. Looks like I divide everything by negative 2. So 12x squared minus x minus 6 equals 0. Does that factor nicely? Does it? Does it? Some of you are 4 and 3. 4, 3. I don't think so. I don't think so. Let's go with x equals the opposite of b, 1 plus or minus the square root of b squared, 1 squared minus 4 times 12 times negative 6 all over 2 times 12. So this is 24 times 12, that's 288, 289. So this is x is 1 plus or minus the square root of 289 over 24. 289, if that's a perfect square, then I should have been able to factor this, but I don't think it is. It's 17. It's 17. So this is 1 plus or minus the square root of 7. No. This is 1 plus or minus 17 over 24. So this is, so I have x is 18 over 24, or x is negative 16 over 24. This probably simplifies as a factor of 3 in both of that. Well, the negative doesn't make any sense here. It doesn't, you know, x has got to be positive. So this is the answer we're looking for. I'm just looking at that thing and I should have been able to factor that. Why didn't I factor that? But anyway, 18 over 24 simplifies. Let's see, there's a factor of 3. So that would be 6 over, actually there's a factor of 6. How about 3/4? So factoring this, I should have been able to say 4x minus 3 times 3x plus 2. There's 9 and 8. There we go. I should have been able to factor it. There we go. Well, this length will be minimized when x is 3/4. I didn't actually find the length. In order to find the length, you got to plug it back in up here. Plug the x in, see what L squared is. That's the length squared. Then take the square root to get the length. But there you go.